Hey guys, today we're going to be going over central angles and arcs in section 2. So a central angle is an angle that has the center of the circle as its vertex, and the sides are 2 radii of the circle. All right, so for example, if I have a circle here, the center is the vertex, and then the sides of the angle are 2 radii. Okay, now the sum of the central angles in a circle with no interior points in common is 360 degrees. So for example, take a look at angle 1 and angle 2 and angle 3. If I add up measure of angle 1 plus measure of angle 2 plus measure of angle 3, that all adds up to 360 degrees. And remember, there can't be any interior points in common, meaning the angles can't be overlapping. They're just distinct angles with each other. Okay, so let's move on to this first problem. All right, so it says to find the value of x, and you see here you're given a series of central arcs, and you need to find measure of angle x. The measure of x. So, okay, so I've got all these, angles labeled here. I have 8x minus 4, 13x minus 3, 5x plus 5, this one. This one here is unknown. They haven't given it to me, so I can't add all of them up and set it equal to 360. But do I need it to be 360? Because here is what I know. I know that this is a diameter, right? And that means that that diameter cuts everything in the circle in half. So these 3 angles together then must equal 180 degrees. So I say 8x minus 4 plus 13x minus 3 plus 5x plus 5 is equal to 180 degrees. If you add these up, 26x minus 2 is equal to 180 degrees. 26x is 182, so x is 7. Okay, now let's talk about an arc. An arc is a portion of a circle, and it is defined by 2 endpoints, meaning it starts and ends at an endpoint. All right. If you have a central angle, it separates the circle into 2 parts, each of which is an arc. So for example, take a look at this central angle here, PQR, right? So this central angle, PQR. Notice it separates the circle, it cuts the circle into 2. This is one part of the circle, that's called an arc. And this red is another part of the circle, that's a second arc. The way in which we measure arc is also by degrees. We can't measure it with a ruler because you can't bend a ruler like that, so it's also measured in degrees. Okay, now, you can obviously see here that when you have a central angle that looks like that, the arcs, right, are not, one is going to be bigger than the other. So a minor arc is an arc that measures less than 180 degrees. And the way we label minor arcs is by the letters of its 2 endpoints. So for example, in this case, this arc is clearly less than 180 degrees. We label it as AB. Now, how do we denote that it's an arc? Well, on top of it, you have to put the arc symbol like this. So that's arc AB. Now, what's the measure? The arc measure is the same exact thing as the measure of the central angle. So if this central angle has a measure of x degrees, then the measure of arc AB is also x degrees. And remember, this has to have an arc symbol on top. Okay, so measure of arc AB is x degrees. Okay, so what is a major arc then? A major arc is an arc that measures greater than 180 degrees. And if you have a major arc, we use 3 letters for it. So for example, this this red one here is arc ADB. Okay, so you have to put, like another random point on the circle like D in order for you to be able to do arc ADB. All right, again, we need to have the arc symbol on top of that. Okay, so why the difference then? Why the difference between arc AB and arc ADB? Well, because if I were to tell you in this diagram arc AB, right, you would think I'm talking about this one. How would you know if I'm talking about the smaller one on top or the larger one on the bottom, right? Is AB that one or is AB this one? Well, in order for us to distinguish one from the other, the top one gets the symbol AB and this larger one gets the symbol ADB. All right? Okay, so what is the measure of angle arc? What is the measure of arc ADB here? Well, if this is x, right? So if this has a measure of x, then this underneath it has to be 360 minus x. So this is 360 minus x. Okay, so we talked about an arc that's less than 180 degrees. That's a minor arc. An arc that's greater than 180 degrees. That's a major arc. Well, what happens when the arc is 180 degrees? Well, 180 degrees, that's exactly half of that circle, right? So it's called a semicircle. Semicircles are also named by the letters of the 2 endpoints of the diameter and another point in the arc. So it's the same notation as a major arc, right? So this one, for example, is arc ADB, like this. However, the difference is these two are the 2 endpoints of the diameter. And if it's 180 degrees, right, then that's a semicircle. So in this case, what is the measure of arc ADB? Well, okay, look at the central angle here, right? The central angle is a straight line. It's 180 degrees. It's the diameter. That means the arc associated with it is also 180 degrees. All right, so let's take a look here. Let's see how the measures of these arcs are gonna pan out. So we need measure of, all these need arcs here. Okay, measure of arc GH, GLH, and GLJ. Okay, so measure of arc GH, right? That's this minor arc over here. And since the central angle is 122, then so is that one, 122. Okay, GLH, GLH, that's this entire arc right here, right? Well, how do we find that one? The red and the purple together are 360. So this is 360 minus 122, which is 238 degrees. GLJ, notice, is a semicircle. So it's just 180 degrees, right? GLJ is defined by the diameter. So it's 180 degrees. All right. Arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of those arcs. So for example, take a look here. Measure of arc XY, this blue part, plus measure of arc YZ, this one, is equal to measure of arc XYZ. Okay? All right. so let's take a look here. So we can add adjacent arcs like that. Okay, so here in circle F, measure of angle DFA is 50, CF is perpendicular to FP, and we need to find each of the measures here. So we need to find these arc lengths. Let's put the arc symbol. All right, so arc BE. Okay, so notice this and this are vertical angles. That's 50 degrees, all right? So that's from chapter 1 or 2, and it's always here to stay. So that's 50 degrees. Okay, what else do we know here? ACE. So ACE. All right, so the first part until B, that was 180 plus the 50, that's 230. Okay, measure of arc DB, this one, that's 180 minus the 50, so it's 130 degrees. Measure of arc CE. CE, it helps to trace these out, okay? C to E, what did I pass here? 90 degrees plus the 50 degrees, that's 140 degrees. Measure of arc CD, all right, so CD is this one, right? And we know that this right here is 90 degrees. And if this little one is 50, that makes this little angle 40, and arc CD is also 40 degrees. And last but not least, I have arc CAE. So CAE. Okay, so what do we have here? This is 90 over here and 50. So this is going to be 360 minus 90 plus 50, right? And that will be 220 degrees. All right, so let's talk about arc measure versus arc length. All right. The measure of the arc is given in degrees, and it is equal to the central angle, right? That's what we've just been doing. Now, arc length is a part of the circumference, and it's measured in linear units like centimeters, inches, feet, and so on. So what is arc length? Suppose you have a circular field here, and this is you, right, on one part of the circular field, and you start walking along, and then you stop right there. So you walked along this red arc over here, right? And you've got your, your cell phone or your watch or whatever, and you're tracking your steps. The distance that you walked along that specific portion of the circle is the arc length. Okay, so now let's try to figure out how we can calculate arc length. All right, so take a look. This is a circle, all right, and this is the diameter. So look at this. This is 180 degrees here, right? That's half the angle that makes up a circle. And that 180 degrees, right? If I take a look at this distance, it pans out exactly half of the circumference of the circle. Is that right? Exactly half the distance around the circumference. Okay, let's take another example. Suppose I have a circle, and in here I have one radius and another radius. This is 90 degrees. 90 degrees is exactly 1/4 of the full 360 degrees, right? Okay, and in creating a 90-degree angle, how much of the circumference do I pan out or do I map out? Well, it's exactly 1/4 of the circumference. So the ratio of this central angle to the full 360 is the same as the ratio of the part of the arc length compared to the entire circumference. Okay, so The way in which we do it is this. Since this maps out exactly 1/4 of the circumference, 2 pi r, that's the formula that we're going to use to calculate the measure of the arc length of any arc. So take a look here. This is the formula that we're going to use. L is arc length. Okay. X over 360. X is the measure of the central angle. Times 2 pi r, which is the circumference. So to find arc length, you put the central angle over 360 and you multiply it by 2 pi r. That's it. It's the ratio of the angle to 360 times the circumference. All right? Okay, let's take a look at this one. We want to find the length of arc ZY. Okay, so that means we need L. L is equal to the central angle, which is 45 degrees, over 360 times the circumference, 2 pi, what's the radius? 12. So this is equal to 1/8 times 24 pi, which is equal to 3 pi. And if you had to round, it would be 9.4. Okay. T and R lie on circle W so that WR is 12, angle TWR is 60. Find the length. Okay, I have no idea what that said, so I need to draw circle W. Okay, here's the center, W. All right, WR, this is the length. WR is equal to 12. Oh, okay. That's 12. And remember, it says T and R lie on the circle. Measure of angle TWR is 60. So TWR is 60 degrees. Find the length of arc TR. So I know those arc symbols are disappearing, but on your worksheet, on your homework, and on your test, it'll all be clearly there. So we need to find the length of TR. This is the length that I need to find. Okay, so L is equal to the central angle, which we said was 60 degrees, over 360 times 2 pi r. Okay, so 60 over 360 is 1/6 times 24 pi again. They're not all going to be 24 pi, I promise. This is 4 pi, which is equal to 12.6. And that is section 2. You can now move on to the homework, which is the 12.2 worksheet, and it will be due on Friday in class. Remember, test corrections are also due Friday in class. Thank you very much.